In this video, I'm going to talk about the FM index and how you can use it. So, what is the FM index? Really, it's just a helper function for a BWT that can speed up some calculations. So, I've started calculating this FM index, which is highlighted in yellow on this side, from the BWT. Basically, all it does is count the occurrence of every single character that occurred before the certain index that you're at. So, of course, the first place the first index is going to have all values of 0 for every single character in the alphabet. But uh, the second index is going to have just one count at t, or the first index. And then the second index right here is going to have a count at c and a count at t, and so on. And it keeps on counting until I'm going to fill out the rest of it. Looks like this. So you might ask, what is the offset down here? Well, the offset just says where that character first showed up in your suffix array. So for the $sign, it is, of course, at the first place. And this is the sorted suffix array. So for the $sign, that happened at the 0 index. For the A, that happened at the first index. For the C, that happened at the third index. And for the T, that happened at the fifth index. So that's what the offsets are. And it's not too complicated. So what does this helper function, like helper data frame or data structure do? Why is the FM index useful? Well, we can use it to find the range of a certain substring. So what does that mean? If you have your string right here and you're trying to find like AT, the occurrence of AT, well, you can use your suffix array to find AT occurring at, and see that it occurs twice because there's two suffixes where the prefix is AT. But you might want to know what the range in the suffix array is. So you can find that range using the high and low of your FM index, or the high and low calculated by the FM index. So this would be the low would be 1 in this case, and the high would be at the end, which would actually be 3, but that just expresses that the range is 1 and 2. So how do you do this? It's the offset of AT, or let's say we're just searching for A instead of AT. If we were just searching for A, the offset of A is 1, and the FM index is at 0, we would do next for A, is the FM index at 0 for A is, of course, 0. So 1 would be the low point. That's where we see the first A. So then let's find the high for A, and that would be the offset, which is 1, plus the FM index at the text length. So the text length is actually 7, so I'm going to put that right here. That's where the counts are, because as you can see, we have 7 characters, and that FM index at the text length for A is 2. So you would just add 2. So 1 to 3 is the range where you see A's. It doesn't actually include the 3. It's just saying, basically, you could do 3. So you could say this is equal to 1, and this is equal to 3, and then we could ask where the number of occurrences of A is, and we would do 3 minus 1 equals 2. So we can calculate from this that there are 2 A's in our suffix array. If we go back up and look at our, or there's 2 A's in our string, and if we go back up and check that, we can see that it's true because this is a small string. And then we can also find the predecessor of a certain suffix. So basically, we can look at the predecessor of either this suffix right here, or we could just look at the BWT and want to find the predecessor of this. So first we would do the BWT at a certain index, and then we would make that equal to the index. So the BWT, I'm going to actually make it this equal to just a constant instead of an index, because that's a little bit misleading. Oh, and we already have that right there. So let's look. The BWT at some point, so let's say BWT right here, is equal to C. So that's what the constant would be equal to. So let's make that equal to C. The offset of C is equal to 3. Okay, so that's checked off. And then, so we're going to say is equal to 3. And then we're going to say plus the FM index at I, which is, remember, we're looking at I right here at 1 for C, for the constant C. So what is that? At I for the constant C, that's 0. So 3 plus 0 is equal to 3. So we know that the predecessor is 3. So the predecessor of 1 is supposedly 3. What does that mean? Well, if we look right here, this is the suffix array, and what comes before it? Well, it would be this. So that actually makes sense. Like the predecessor for this would be for this part, this string substring that includes everything except for the C at the beginning, trying to highlight it, would be everything including the C, which is 3. So basically those are two really useful calculations you can have for the FM index. Just a reminder, if you saw this down here, the memory that an FM index takes up is actually technically the text length plus 1 times the alphabet length, which makes sense because we have that going up and down. The offset is also saved, and it goes across this way. So I hope you enjoyed this video, and I hope you guys have good luck with FM indexes in the future.